Sorry, my laptop issue. Okay, so we will start. So we will break down the formula. So first let's consider this 1, 2, 3, 4, 5. We'll consider simple data 1, 2, 3, 4, 5. So in the range, we had considered only 1 and 5, okay, in order to find the quantitative value. But we will consider each and every point. So first, mean of the data. So mean equals to 3, average of all 5. So the formula, the first part, it is very simple. Each data minus mean. So which means like 1 minus 3, that is x1 minus mean. So 1 minus 3, 2 minus 3. So x2 minus 3. Okay, 2 minus 3. So let's calculate that. So 1 minus 3, 2 minus 3. So 3 minus 3, 4 minus 3, and 5 minus 3. Okay, so it's simple formula only, right? So no confusion in this. But why are we doing whole square? Okay, that is one nice thing to understand. Why are we even doing this whole thing, the square? Okay, we call this the sum of square. So what is 1 minus 3? So the answer is minus 2. And here let's say minus 1 or 0. But why are we doing this whole square? So we are not interested in the how the movement of this 2, which means whether it is the negative movement or the positive movements. We are only interested in the magnitude, which means like we are only interested in 2. We are not interested in the minus. So we are doing the whole square of this data. So minus 2 whole square, we will give 4. So minus into minus is plus. So we are eliminating that symbols. We are eliminating the variation, the movement. Hence, we are doing this whole square. Okay, divided by n. Divided by 1, 2, 3, 4, 5. Number of population, but divided by 5. Okay, so break down the, if you understand the formula, it is very simple. Each and every data minus mean, you are doing the whole square of the answer. Why? Because sometimes you get minus. So when you do minus 2 whole square, that is minus 2 minus into minus plus, you're going to get only the positive value. We are only interested in the value, but we are not interested in the symbol. That is why we are doing whole square divided by n. Okay, so if it is sample, if we are taken sample, then it is n minus 1, 5 minus 4. Okay, first we will do one thing. First take your Excel sheet and we will break down the formula. We will not do it manually, but with Excel we will try to do. Okay, so first we will have a data serial number. You can take any data you want, but I had taken some minutes for exercise minutes. So 20 minutes. So some people or exercise, I've collected data from the people who had exercise. Okay. Okay. My internet is, I think it's not working. Let me know if my voice is not clear. So just take any random numbers, whatever projects, like if you want to record your, let's say that 5 minutes, 10 minutes, you can take anything. Okay, this is your data and you have 9 record. You can take any record, you do according to your data. Okay. So what is first find out mean. Okay, we want mean of the data. According to your data, just click here and computer generated mean. Okay, 2.29.4. Okay, so now let's go back to our formula. What is the formula? X1 minus mu. Each and every data minus your mean. Okay, now let's go to the calculation. What I'm going to do here, so you mark it here, X minus mu or mean. So here each and every data. So 20 minus your mean, 29.4. Okay. So this has to be fixed. Otherwise it will see, it will move. So if you drag it like this, it will move. Okay. But this B13, I have to fix it. So fix it with your dollar symbol. So this and all we will learn in the class, but just fix it with the dollar symbol. So B13 will not move. Any doubt, let me know. So this is the part 1 of that formula. Each and every data minus mean. Okay. So this is just the random data. And for the random data, you have to calculate mean. And according to the formula, each value minus mean. So when you're doing so, make sure you fix your B3 or you just do B2 minus 29.4. According to your data, you do your with your own data. That only will be perfect. Then you will check on your own. So do not copy this data. You create your own data. So okay, the next part of the formula, as I said, this minus, right? The minus is actually we don't require. Minus indicates it is going in the negative direction or pass. We don't need the direction. We are only interested in this 9.4. So we are going to do x minus mean whole square to the power square. Okay, so it's just nothing but you gonna do 9.4 into 9, this into the same value equals to this into this 2 times. Okay, you got the positive value. So the weightage of the value is important, but not the direction for this formula. So even 9.4 is equal to 88.36 in the scale wise because we've done power 2 for all the values. Okay, this is the second part of the formula.
Ma'am,
Yes.
can you please tell how to calculate mean in Excel sheet?
You just, click everything, you will get here the value, average. So otherwise, everything, add everything divided by total number. So otherwise, for an example, usually the sum is 265. 265. So mean equals to 265 divided by how many units you have? 9. 9 observation. So 29.4. But I just copied down.
We can use average formula, right?
Yeah, you can use. Yes, we can use average.
Yeah, that's
Yeah.
Vandana, could you please explain the
Yes.
second part once again? Like x minus mean square, square, that one? Yeah.
Whole square. Okay.
Yeah, whole
So
square.
according to the formula, so we have to do this part. So we did x minus mu. Okay, that every value minus me. But we are doing the whole square. Why? Because we will get this negative sign. When we are doing 1 minus 3, we get this negative sign. So in order to eliminate the sign, but keep the value in consideration, we are just doing minus 2 into minus 2. So minus 2 into minus 2 equals to positive 4. Minus into minus plus, that will go off, and we will consider this value like this. Value plays major role rather than this. I think mine got shifted. Oh, sorry. Okay, the value plays major role, but I eliminate the direction how it is going. So 9. 9 is what my interest is. So I don't want this minus. So we are doing whole square for all the data. So here I did C2 into C2.
I have one question, like how to apply this x minus mean into Excel, that formula.
This formula, the whole square formula, for the whole square, I just did a simple in my own way. I don't know if there is one Excel formula. So C2, I did into the same C2.
Okay.
So 2 times you have to multiply, then you eliminate the minus. So we are doing whole square only for that purpose, in order to eliminate the symbol, but 9 is having weightage. But even if you do whole square, see, you are having the same ratio, which is 9, you are converted 89. 0.5, you've converted as 0.30. So you are giving the same weightage. 10, 111. Okay, so that weightage you've carried out in the formula, but you eliminated the symbol. And one after finishing, okay, so once you have finished, the last part, summation of this. So what is summation? You just add everything that you found. Okay, that is the meaning of this mark, summation mark. Summation of your this formula. Actually, the formula will be like this: summation of your xi minus mu the whole square divided by n. Okay, so we did this part. Now summation, we call this as sum of square. Okay, this part we call it as sum of square. Okay, I'll write here. So we just have to add everything. That is the meaning of that summation mark. Sum for me it is 6222. Equals to sum of my all these numbers I'll write down the formula. Xi minus mu, the whole square divided by n. So this summation, we call this as sum of square. So my sum of square is 622.
Hello, ma'am.
Yes,
No, like that's x minus mu. Uh, I'm just
yes.
confused how to calculate that in Excel. It's not getting it. Theoretically, I understand that, but how to do
You
that in
need
Excel?
mean for this. Have you got your mean?
Yes, ma'am. I got my mean.
So here the x minus mu, so 20 minus 29.
Yeah, I got it. But how
Oh.
to implement that in Excel?
So Excel, what I did is that, okay, I got it. So
Mhm.
20 minus B3, okay. This B3, guys, don't forget to fix it, okay. Otherwise, it will not match it. If you don't fix it, it will move. This is the mistake from your Excel? You have to fix it with dollar symbol. And then you will get this answer, okay. So when you are scrolling down, this B3 will be fixed. Okay, I think that would be the, so please check it, otherwise the whole work would go wrong.
What is n here?
Yes, n is the number of observation. So if you guys finish, then go ahead and do the formula. Number of observation.
Here's mine observations.
Yes. So those who have finished, now calculate your variance. So variance equals to your sum of
16
square divided by, let's say I will put
16
number 9. What is it?
69.13558.
Yes. And verify with your system. Okay. So let's say for an example, variance is the formula. So variance of the population. Okay. And I am trying to find the variation or variance of this, now this data set. Let's see if we are matching with the system. I think fine. So this is system, this is our calculation.
So in projects, we have to calculate it in this way, in this method. Cannot use system method.
No, we can use it. Like you will not be asked like, produce a calculation. So we just, studying. Otherwise, you can directly find out.
Okay. So Excel has a variance formula directly.
Yes, it does.
Mm.
So what's the usage of variance? Like if we do have means, like what's the purpose of it?
So I think the purpose we have discussed more than an hour. The purpose is that how far it is distributed, how far this is concentrated. See, the variance or standard deviation is a measure which will give you the how far it is concentrated. See, for example, instead of 2, I input 100. So you see, it is increasing. Your variance increases, which means it is giving you some measurement for us to understand whether they are closely related or whether they are clustered. So instead of 100, let's say I can reduce this 69 as well. Say, let's say, for example, this 40, I'm converting to 20. So as you see this, let's say you're working with a data set. Okay, let me go back and what was that, 40, right? So let's see if you're working with a data set, and whatever data set that you work, the first in Python, we have this first code. Okay, the first code is that we always find out variance and the standard deviation. If you have drastically, like let's say 1000 as a point, 1000 or 5000, which means your data is widely distributed. At least practically some 200, 300, 500, it is more than good. But if you have drastically 10,000, because you're going to work with some thousands of data set, you can never get 69. Okay, practically speaking, you may get some 300, 400, 500. But if you have drastically some 10,000 or 5,000, which means your data points are not in cluster.
So practically, what is the conclusion of the variance? Like, what is means how we reach to a conclusion by reading the variance amount?
So we will conclude that by seeing the our value. Okay, so here when I have 69, I'll understand that okay, this is close enough. Although see, if you put 2, 2, 2, 2 and you calculate variance for all this data, you get 0 because they are all fully clustered. But our data practically, it's not going to be like this. Okay, somewhere you record 2, somewhere you record 5, somewhere you record 7, so 3 and 9. This is fine. Okay, this part where you consider it as a acceptable range. But if your data is 2, 5, 7, 3 and one data is 9, and you see this drastic point, so somewhere it raises alarm for you to go and check back your data, whether your data is correct or should I make any changes, should I segregate it into two parts. So let's say for an example, there is another way of looking things. So let's say you have data like this. So you calculated your variance according to your project for all the information, and you see that this is drastic. So what you will do, you will bin it. We call it as a binning. So what you will do, you will consider this as one data set. You bin it, which means you divide, and you consider another set of data set into second class. So you've divided two classes. Now you try to create again variance and try to bring it down as much as possible, at least a workable range. Now you work, so okay, fine, now I got my, fine, at least it is looking better than 1000. You work, you continue with your work. As of now, it's going to be little overwhelming when you kind of put everything, you don't even understand where to apply, and but you will apply and you will get that when you start doing projects and when you start learning different tools, you will side by side you will understand all these things.
So in
Don't
this
worry
case,
if you are not getting or if you are finding it very confused, or don't worry about that, it is normal. Okay, even I was there in that part, so in that phase, so don't worry. Just understand this one number which will give me the idea of the how far this data is clustered. That's it. That one understanding is enough. Later on you will see it.
One question, like, we got that logic, but when do we expect? I mean, when do we consider that the output is like a drastic difference and it's not acceptable?
Okay, so that is one. It's not a I cannot straightforwardly tell you guys that 1000 is after 1000 it is, because that is the analytics. Okay, it differs from data set to data set. So let's say for an example, if you're working with a data set that is closely like, that is what, there is no a definite answer for this question. It depends upon your data. So let's say, as one person pointed out, that a particular task for particular minutes for this task, we already know it has to be 5 minutes, between 5 to 10. Okay, so if you have any vast difference like 60 minutes, you will get some point where you, like, let's say 500 as your variance, then you will go and verify your data, you will try to adjust it. And but there is no definite answer that after 1000 it is widely distributed, or after below 500 it is closely. It is not like that. Depends upon your data set, because some data set there has to be closely, like for example 5 minutes means 5 minutes, 10 minutes means 10 minutes. So your data itself partly is closely related. Okay, but for some data it is not like that. Some people will earn 5000, some people will earn 5 lakh, but you cannot expect 100 as your variance. We cannot expect closely related, or we cannot expect a point. It is up to our decision. Sometimes we will go by, okay, 500 is okay, fine, according to this data set we get 500, that itself it's good, so we go ahead. So that is what I cannot say, that it depends upon your data, but when you start working you will get the idea. Because for this data set, okay, I cannot, let's say tomato price, I cannot expect more than I cannot expect it for 20. So this period I will see, we are making concise decisions, right? For tomato, I cannot, expect anything below 50. I'll have to pay 50. So there is no definite point, but we make our concise decision. Similarly, you will get to that point, but when you start doing projects, you will get to that point to decide. Okay, but there is no definite answer for this, whatever you are asking. Just understand, if you have huge data, or and your standard deviation is something like 5000, which means like there is an alarm, you have to go and check it. Again, there are so many ways you will check, different ways, like you will check minimum, you check maximum, you check q1, q2, q3. When I don't think I would take Python class for you guys, but Python trainer will explain you how this variance plays significant role in your data. So don't worry about that part.
Okay.
So in this case, I have one question. In
Yes,
this case, you said that we have taken minutes, and in minutes, it means that the variance in this data is 69.13. So it means that the data goes up to 69. That's what it means. Like,
I didn't understand. Sorry, come again.
I'm not able to understand this variance concept, how to apply it in real world project, like practically.
So what is the, say for example, let's take practical data. So this is
Yeah.
some
So
one data that you
Vandana,
have.
Vandana, I
Yes.
think he's asking because I'm also confused because the variance is showing 69. But if you look at our data set, so there is,
No,
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 don't. No,
yeah,
this is an independent unit. Do not get confused with unit. Okay, let's say this is seconds, but do not get confused with your units here. So if you have independent, don't consider with this is minutes and this is 69. So do not confused with that. It's just an independently take it. So
but
sometimes you get 5000 as an answer, doesn't mean that it's like I have to compare it with my existing data. It's not like that.
so,
So let's say for an example here, okay, this
so
is your
the
real
question
data.
is that how the variance is related to the data set means what is the relation between data set and the variation?
Yes.
It's just the number. It's just a individual number where uh, it's just the number, guys. So based on number, you decided whether this is, see, this is sales amount. Okay, so let's
Yes.
calculate the variance. So it is in rupees, right? It's in a dollar. So let's calculate variance of this data set. So you got huge data. Okay, this is huge, wide, in a big number. So what does this implies? It's just a simple number. It's not even related to your unit, okay, or dollar or whatever. It implies that my sales start from 11 and it goes up to 37,000. See, 11 is the smallest point, and let's say 37, it is so huge, and it's just a small alarm for me. Okay, like, okay, this I cannot work with such a huge variation. So what I will do, so I will just try to segregate my data. Let's say I will put some filters between, and I will take, maybe I will consider working from 10 to 1000. So you create one group. So in this I will not have much data. Okay, so let's see, I have grouped one data. Okay, that is from 10 to 1000. So let's calculate variance of this data set.
Just press. Yeah, okay.
Yeah, variance of this data set. So so instead of such a huge variation, okay, which means, so instead of like 1 lakh, I find this as an acceptable point. So in, like, I cannot say that below 1000 or below 1 lakh is a higher point. So instead of comparing to 1,74,000 as my variance, I consider this as an acceptable range. Okay, so like this, I will try to segregate my data, bin it or group it, and then I try to reduce my variance as much as possible. But do not consider like I'm trying with sales amount, whether this is telling something about the amount. No, it is just the a number, which is like, which gives you
So,
a better idea.
Vanthana, just try to understand the definition of variation, because as you mentioned that it is not related to the data set, because we have set the, consider the
It's
data
not,
from 10 to
I didn't say
1000.
that it is related to data set only, right?
Okay. So, but we, consider the data from 10 to 1000. But if you look at the variance, so it is coming around 74,985, right?
Yes.
So, how, just wanted to the definition of the variance in layman language, means how do we use it and when do we use it? What is the definition actually? I mean, we can, look at the definition on Google as well, but just try to understand, because here, uh, literally, I am not able to understand that what is the use of variance if we look at the, data set.
The use of variance is what I've been telling, right? Like, see, if you have one number and if you have like huge numbers in your data set, your variance will be very high. See, that is what, like, if you're not thinking about, if you're thinking various other things into picture, then you will create that confusion. A very simple thing that I was telling, that do not overthink other things and all. Just very simple. If you are having a data set and you want to see how far they are related, okay, which means like you are doing your project is about sales amount, how far they are related. But instead of 2, 3, 5, 6 and 7, you have 50 in place. This 50 is not related with your data set. Okay, this is outside the range. How to find it? By means of a simple calculation called variance. So variance is like, it's going to give you a score. We will try to, based on the score, you should try to reduce the score if you feel that, if the minimum, this is my minimum is 2 but maximum is 50. So you see that minimum and maximum is having wide lead, like it's like the distance is so high. So what I would like to do, like, I wanted to try to reduce my minimum and maximum first. So let's see, I will work with 2 and 6, so that my variance will try to reduce, and I will get some data that is closely related. That's it. I don't see anything, very complicated things here. Why it is
Okay.
so that
Now got it. What I understood is that it's a method to measure the dispersion of the data. So
that's
it's
what I said
depend.
initially
Yeah,
also.
yeah.
So
It
how,
depends on, yeah.
yeah,
Okay.
so that's what I said. Like you need to work with the closely related data. You cannot work with your normal cars, including
Hmm.
your Audi or BMW. That's it. The concept remains same. Initially, we saw the graphical representation by box plot. Now we are getting a mathematical, just one value to understand it. That's it. So
Okay.
initially we did a box plot and we try to understand the point that is outside. Now we are doing the same thing, but we are just taking it as a value.
Okay. So it
So
depends on us on project to project that how much variance we can afford as per the project requirement, right?
correct. That's what. So here I cannot expect 70 or I cannot expect 100 because your data is like 1000, 4000 points. You cannot expect practically 500. But for here, when your data, it's like close to, I think, 1 million as your variance, acceptable range you can decide. That will come when you start doing lots and lots of project. You will understand for this data set, okay, at least 5000 is okay, fine. Then you start doing your project. That we cannot definitely tell you guys to take this as a point, because your data set for your managers, you feel like, okay, group this and you do your other stuff, then you will proceed. Okay, so here I cannot definitely tell you to take that particular value. Depends upon the data.
Okay.
Just do not overthink all these things. Just as of now, so do not think about even your project. When you are doing project, you will understand. But right now, you are only discussing about how far your measures or how far your data is distributed via one measure. Okay, so this is our variance for our data, that is 69, and computer generated one is also 69. So we either go for variance or we either go for standard deviation. Okay, both are same way. Standard deviation is nothing but square root of everything. And that's the only difference between variance and why we are doing square root, because here we are taken sum of square. So we did a square of both. Now instead of doing, so when you're coming into standard deviation, we are rectifying that one issue. So here, in order to eliminate the minus, we did square. Okay, so we are representing this as a sum of square. In order to rectify, so in order to back to normal, you are doing again square root. So square root of this, but both remain same. Okay, so variance, so square root of this is 8.14. So if you calculate the standard deviation of your data, this is 8.31. Okay, both same way of calculating. It's just that we did squares. Okay, in order to come back to original position, you are again doing square root of your entire formula will give you standard deviation. You either consider variance or you either consider standard deviation, but the widely used one for the dispersion is that standard deviation. But variance and both are fine. Okay, so you can either use any one, but widely accepted or widely used by the analyst, standard deviation.
There is a lot of difference between variance and standard deviation value. Variance value and standard deviation value.
Oh, sorry, come again.
There is a lot of difference between variance value and standard deviation value.
You don't compare these two. Okay, these are independent measurements. Okay, so that is what you don't, there is no, it's like for an example, these has to be close. It can't be close because we are doing square root of one value. So this is 125. Let's say it's variance, standard square root of 125. I think it is 5. I think what 25, I guess. Sorry, 25. So you are doing square root of one value. So it can't be, definitely it can't be related at it. You can't have two values that is in sync. So why we are doing square root and bringing it back to 25? Because we did squares here. So we did 9 into 9. So here, instead of eliminating this minus symbol, we did square. So we are bringing it back. So we are doing square root of the whole formula. That's it. So you can't expect these two to be in one sync.
Okay.
Okay, 25 into 25, I think 125, right? So that is what? This is 125. Let's consider it as
25
a
into
variance.
25 is 625, ma'am.
So what is the square root of 125? Square root of, let's see, square root of 125. 11. Is it 11? Let's take one simple example. 25. I think square root of 25 is 5. Am I right? Okay. This is standard deviation. So you are just projecting it down, but we are not doing anything extra. Why we are projecting it down? Because we already did somewhere this double or doubling your this value. So that's why we are just bringing it down for your standard deviation. So both are independent in nature. You can use either one for your finding or one for your distance calculation. So even the same thing, if you increase one value, your standard deviation will increase. Okay, 23. Instead of 8, it became 23. Okay, so based upon your project, you will decide whether you go for 23 as your normal standard deviation or whether you wanted to remove the outlier. Depends upon the project. Whatever we spoke for variance, it applies for your standard deviation also. So just one thing, variance will be usually a very big number and standard deviation is much lesser than variance. Okay, so do not get confused. For example, when I was taking the real data, so variance will be a little smaller number when comparing to your standard deviation. Sorry, standard deviation is much smaller number. So variance of this data set is, you got huge number and standard deviation is, okay, so 4,000. So here, if you are feeling that if your manager decides and if you guys think that this data set is having huge variation, when I say variation, it doesn't mean it can be via by variance or it can be standard deviation. You consider any one. So let's say here for standard deviation, you think that 4,000 is so high. I don't want to see such a variation in your data. So you group it, group some data and find out the standard deviation. So your objective basically bringing down this value to some acceptable range according to your project after discussing with your manager. That's it. So any doubt in this calculation? I hope many of you guys must be having so many doubts. But when you are doing projects, right, you will slowly understand what we are even trying to do and what we are trying to do all these formulas. At the time you will definitely understand. Okay, so because without this we can't do anything. Every project we have to calculate this. So without this phase you will not move further at all. Like at least you will see the standard deviation and variance. So don't worry, you whenever we are taking any module, even in Alteryx, Power BI, wherever you do the projects, you will see the standard deviation, verify, and then only you will create your models. So this part is an inevitable part of your project. So at the time you will get it, you get the idea.
I am having doubt as to the need for this variation and standard deviation, like in every data, or like if why do I have to even relate that data to each other?
Sorry, what was that? Why do I have to relate
Yeah,
the data?
means yeah, relate the data. So if we don't relate the data, so what will be the conclusion
So
of
if you
that
don't
data?
relate the data, so let's say this, what happens if you include BMW car prices in the normal, so you've invented a car and the car is somewhat very closer to your I-20. But you've collected all the car prices in India, which holds Audi or BMW. So what happens? You think what will happen when you're doing analysis? So your objective is that you want to fix the price for your car that is very close to I-20. But your data is having BMW price and other features. What do you think it will happen?
Will give certain kind of incorrect data, like
Yeah,
the
that
data will vary
incorrect
a lot.
data. So it will show that incorrect mean, incorrect median, or median might show incorrect or features, everything incorrect. Let's say for an example, you have collected customers salary for maybe marketing purpose. The one who buys Audi or BMW, their salary would not match with whoever buys a I-20. So you've included their salary into our the normal group of the people. So what will happen? Everything might, your model will not work properly. Your model will learn wrongly. It will produce bias. So maximum we try to work with the data that is relevant to the project. That is more important. It is not about grouping the data. It is about relevance to your finding. What is your objective? That is what yesterday we spoke
Okay.
about this whole. It is your data has to be relevant to your objective. You can include Audi or BMW, but if it is relevant to your objective, you can include it. But your objective is to price a car that is close to I-20, then these are not relevant. That's why. So in order to
Okay.
find those irrelevant data outside range or some data that is not closely related, that is why we use all these measurements. This gives a certain idea to without, because we are going to deal with lakhs of information. It's not 9 row. You will have 50,000, 8 lakh rows. You cannot check each and every row, but this point might give you a little idea about how the data is inside. What is Q1, Q2, Q3 will give you a little idea about your data. So that's why when you are doing project, you will definitely understand where these values are playing major role. Because if I
Okay.
say, even if I say 10 times, that is the speciality of statistics. Even if you see 10, 100 YouTube videos, but when I ask question, we will not, you may not able to answer it, because I was also there in that same. Even if I refer 100 pages, but when interviewer asking something, we'll get terrified. Okay, because these concept will not sit in our head in first time. So that's why be patient when you are doing projects. You will definitely understand when you're doing module after module, you will definitely understand these concepts. But when you're going for interview, don't hesitate. Like by heart this formula like a 10th standard student, at least whatever we say, just take a note and by heart and go. Okay, there is nothing wrong in that, because will not sit in our head properly, these concepts. Okay, now let's take a break for 5 minutes, because we wasted so much time last hour. 12:10 we will start. Okay, after this over, we will go to another simple concept, the graphs. Very simple ones. You will not have this much headache, so don't worry.
Vanthana, could you please share the sheet also with us?
Yes, yes, yes.
So Vanthana,
Yes.
so have you shared the sheet, yesterday sheet
Yes.
with us?
Yesterday I did no fundamentals. Okay, I'll
But I
share.
haven't received any email.
Oh, it will be in your LMS.
LMS. Okay.
Yes, but I will share
Okay.
here as well. Okay, so most important thing is that graph, because for analytics it is very important, because whatever our finding we are going to visualize it, any tools that you follow. Okay, but these concepts you have to keep it in mind, whether you follow Excel, Power BI, it doesn't matter. But these concepts, right, the way of presenting the information, it is very important. I hope you guys are back. Okay, so I don't have any notes because we are going to see everything in Excel classes. We are going to produce the graphs with our data. Okay, that's why I did not prepare. I have one small PDF is there. I will send it. Okay, after finishing this class, I will send it. But there is no separate notes for this. But that PDF itself is good. But let's see. First important graph is that we always have this very important thing. There are certain rules for producing the graph. Just when you're doing assignment in your Excel, do not simply drag, drop, and do some. We are not here for designing. We have to produce the data in a meaningful way. So certain rules are there that we have to follow. Very simple ones. So whenever you are trying to segregate things, or whenever you are trying to project in a uh, in a in a separate classes, or in a separate projection, or let's say in a bins or in a group. Okay, so the most widely used one is that column chart. So one each group you want to project it. So the widely used one is the column chart. And what is our x-axis? We have categories. And y-axis is normal numbers. Okay. But some people, what happens? Let's say this is Chennai, Mumbai, Delhi, and Goa. But some people, what happens? They will they will do something like this. This is, let's say you're projecting for Chennai, Mumbai, Delhi, and Goa. This is absolutely wrong. Okay, this is a line chart. You cannot show the trends. Or okay, let's do one thing. I'll quickly take the data instead of doing something like this. Okay, I'm going into pivot table, but we will see everything in our class only. But just to show it real, without me drawing kind of things. Okay, so that's why I'm just quickly going inside. So let's say I want to show something categorical data. Okay, so each channel, this is my sale amount. So if I want to show something like this, the best graph for categorical data is your column or your bar chart. So here are the list of the charts that are available. The most widely used for your categories is your column. Okay, cluster. So we'll see the other types of column. We'll see the widely used is your column. But what I'm telling is that it is so wrong to use something like this. Okay, never do that. I've seen many startup people doing all these, freshers doing this mistake. So never use line chart for your categories. Okay, this is very wrong. Never project it something like this. Line chart is only for your trends, showing the trend. Okay, so you should have continuous data to show the trend. So what I meant by continuous data here, or tell me one example where you can, what kind of data you can use line graph?
The stocks.
Okay, stock is one good example. So what is your x-axis and what is your y-axis? If you think about stock.
X-axis will be month
X-axis will be your month and
and
y-axis is your
y-axis,
stock price.
yeah,
Yeah.
stock price.
Am I right? So what
Yes.
about this month? Okay, so when you take month as your x-axis, can you show something like this? This is the interval, the scale of interval we were discussing. Can you take Feb as first, March as second? You cannot take it. You have to follow an order. Jan, Feb, March, April, May. So this order, right, it is very, very important for a line graph. So when you follow the order, you will get the trend. So when I say continuous data, it meant by the time. Time is one example for your continuous data because it cannot jumble. It cannot be jumbled. Here I can show store as first. So for categorical data, you have to use either column chart or your bar chart. This is the bar. Okay, but do not take your line graph. Line graph is only for your time related stuff, which is the x-axis has to be in a continuous data. Only then we can find some trend. Why we are marking the stock market using, nobody will mark stock market using the bar chart. Okay, they will always mark with a line chart. If you see the dollar price or whatever, why? Because we see trend. So here I see this upper graph, the graph, and here the lower range. Maybe in the month of May 15th, the price may go high. Month end, the price may come down. So you will find out certain trends. Line graph is used only for the trends. Okay, so there is no compromise in this. And even for your assignment, I don't want anyone plotting your categories into your line graph. Okay, this is point number 1. And when you talk about your bar or your column, you have two types. So one is your clustered column and one is your stacking. So the problem comes when you are comparing two things. Here I only used my channel, but you want to compare two things. So let's say for an example, you are comparing sales versus cost. You are comparing boys mark versus girls mark. So when you compare two things, you have to decide properly whether you should go for cluster or whether you should go for stack. So I will give you one example. This is total class. You got 100 students, and in that girls 60. Okay, this is your data. Okay, the data is 100 and in that girls 60. Which one you will go? Which one you will choose? And why?
Stacking.
Stacking.
Yes.
Okay, and why?
Because there are only girls and boys, two entities only. So it
No,
will be
I don't
easy.
have boys here. I only have total class girl 60. This is my data. So which one you will choose? I don't have boy here.
Stacking only because there are total students 100 and the girls we can mark as 60 and the rest are the students.
So it's the stacking doesn't work in this way. Okay, so if you think about your axis 10, 20, 30, 40. Okay, so you cannot show anything separate. Okay, so what happens when you stack 100 upon 60? What will happen? So what will happen when you stack your 100 and on top of that you stack 60? What will be your y-axis now? What is this point will be represented here? What is the value you gonna see here?
160.
160, but do we have 160 students in our class? The total itself 100. In that girls 60. But when you stack upon one another, but you may show wrongly to the user. The user will not understand. We understand. Okay, this is 100 on top 160, but when you see the graph, you may project it wrongly. We don't have anything 160. Okay, but here if you
If we stack below, like the below marking as 60 and the rest 100,
whatever you
can
mark, it will mark 60. And if you on top you put 100, it will not take this 100. It will consider 100 plus 60. Okay, it will show as 160. So let's say for an example, I have this data. So sales amount and cost amount. Okay, let's take our sales and cost. So we'll plot your So I'll take cost amount. Okay, so in order to keep it simple, I will convert this into percentage so that we'll quickly understand. Okay, so you see sales amount 7%, cost is 8%. So let me mark a graph for this. Go for stacking. Okay, so what is my catalog? So you see this graph. Okay, here this graph is not clear. Let me take normal graph without any 3D. Okay, so when you see here, see there is no way where we can avoid showing that. You cannot avoid showing this as your total. Like people, when they quickly see, they will mislead, or you might mislead the information that this whole bar, this catalog is having something for 16%. But why we cannot show? Because our sale amount is 7%. In that, cost is 8.33. These measures are totally not possible to even compare anything. Let me take one more example, because sale amount, actually we should not show this in percentage. Okay, you should have shown this only in numbers, but let's consider, for example, we will plot here. So let's say total sales as 100 and total cost as 60. You cannot show this as 100 plus 60 as like in this graph. Okay, so you are showing something wrongly, or you might quickly, somebody can mislead that this particular catalog is showing 160. Okay, in this case it is better to show side by side. 100 as a graph point, this is total and this is cost. In that total sale, my 60 as a cost. Are you getting the logic? It is not something, it is like you're projecting it wrongly. Otherwise, your measures, everything's are fine. Your total sale cost is fine, everything. But when you're projecting it in a graph, nobody will understand what is inside. Everybody will see the graph and will conclude something. So if you put stacking upon one another, everybody will see the graph point. So you may project something as 160, but you don't have cash in hand as 160. Your total cash in hand as 100. In that 100, only 60 is your cost. So if you stack upon one another, something, this graph may mislead the conclusion. Okay, that is one small point. Okay, is it okay, whoever asked the doubt?
Yes, ma'am, it's okay.
Okay. Because even here, even if you try to see, even if we add data labels, because it's a simple graph, but in terms of your real data, you will have more charts. Even if you try to justify with your data labels, still be some people will feel confusion about this, why this is having 100 and 120%. Why this store is having 120%. So in order to avoid that small confusion, so we will go for cluster. So in this case, this is good. Okay. So total, I'll not convert this into percentage because percentage is totally wrong. Okay, so I am projecting something that is close to 2 million, or see, adding both together, I'm projecting it as 2 million, but it's not the case. Okay, so total sale cash in hand is 16 something, okay, 163, but in that my cost is 74. So we will have to go for cluster. So this is an example I was telling about your boys and girls. Total class is 100, in that girl 60. So you cannot stack upon one another and show your graph as 160. Okay, so in this case, you go for your cluster. But let's say for an example, another case where girl 60. Boys, 40. So what kind of graph you will use? Either stacking or clustering.
Stacking.
So stacking. Okay, so 60 and 40. So what is total is 100. So what happened to this cluster? Is it wrong?
This will not represent the correct data for of a class.
No, why not? Why not it will not represent?
We
Your
can
graph,
represent them in both ways, stacking also and
correct.
cluster
Actually,
column
both
also.
are correct. Yeah, what Drishti is telling is correct. Both are correct in this case. Because see, always check your XY axis when you are plotting. Okay, the key thing is that even though you're logically correct, everybody will see your axis. Whatever your projection, it has to match with your axis and with your logic. So here, if you show girl and boy as 100%, this is also correct. Let's say you're showing girl and your boy. Girl is 60, boy is 40. Boys are 40. What's wrong in this? It is also okay, right? Your graphical standpoint, this is also correct marking. This is also correct marking. You are not showing anything that is exceedingly, or you are not showing something that you don't have. You have 100, you're showing. You have 60 and 40, you're showing. That's it. So this is what I was emphasizing, that do not show something that is out of range, or do not show something that is not is happening. Like there is no sales plus cost. Cost is inside sale. You cannot stack upon one another and show them. Okay, in this case, both are correct. The only place where you cannot stack is that if one measure is inside the another measure. Because I'm selling it for 100, in that cost is 40. 40 is inside this 100. Okay, so do not stack upon one another. Then you may show this as 140. That simple logic only. Okay, this is where some confusion may happen. Otherwise, everything, then you can go for normal way. Okay, so when you can stack, I will also show one example. When it is good to stack. So let's say for an example, class. So 163, okay, this is my total sales for my catalog. I'm coming to 20K is from deluxe, 51K from economy, 92 from regular. I add together, I still get the value. Okay, I'm not showing something, anything that is out of range, or I'm not exceeding something. Okay, so here it is okay to stack because my sale is matching 163. And in that 163, you make division and show. Okay, the small part you remember. Do not show anything out of range. Okay, so again, this is about bar and your bar chart, columns, cluster. And one more thing is line graph. Line graph is used only for your time series plot. And one more thing is that very important thing is that pie chart. The pie chart is used for cross-sectional data. Okay, yesterday I taught you about cross-sectional data. What is cross-sectional data?
It's a recorded data.
Recorded what time?
Same times recorded
Same
when
Same,
the
time.
happen.
yeah, same time,
Yes.
yes.
Why we are using this kind of chart for the cross-sectional? Because there is no axis. You cannot do anything apart from the value. Okay, you cannot show the time. That is why this pie chart is used for cross-sectional. So let's say result came out, and then so English mark is 30 mark. This is another 60 mark, 10 mark. The way of representing is wrong. Okay, so girls 90% have passed and boys only 10%. So if you see here, both have recorded same day. The result came same time. Okay, you cannot show anything with X and Y axis. So you only show few variables under this one small. Again, do not do your pie chart something. So some people have crazily produced pie charts. So let's say for an example, so let's say I have huge data, huge variation, all recorded same time only. I don't have any date column here. There is no date, all recorded in the same time. So sale for each and every product. Just because everything matches, I cannot produce something like this. Okay. So this is also a pie chart that is recorded same time for various product, but this is wrong. Pie chart will give you brief information about your whole data, the highest level. So what I will do, this is fine. Highest level of your data. So let's say for an example, instead of product, I will add continent. So Asia 51, 52K, or Europe this much. So this is fine. Okay, pie chart doesn't mean that you show everything and put some design. It's not like that. Okay, brief level information, cross-sectional data which produced same time, but very brief level information. Continent-wise, channel-wise, where the segregation much less than 10. Do not add more than 10. It looks very messy. Pie chart is also equally very important chart. Okay, so these are the ones that you have to keep few things in the mind, but we will see this combo chart and we will see other charts in our class. Okay, histogram, box and whisker we will see in the class when we are plotting again. Okay, so I will send you the PDF for your just to have handy. When you are plotting, you have to at least for a few days just have a look. This is for Power BI, but you can follow for every other tools. Okay, so let's quickly first comparison. For comparison, the best plot is that always this green color one. So these are advanced plots. Okay, these are from R and other stuff. So don't see that. The one for comparison, either go for bar or your column. Okay, change over time. If you want to represent something with time, we go for line. Okay, again these two are advanced plots by Python and R. Okay, with the Excel and Power BI you can produce these two. And spatial analysis represents our geographical data. So there are graphs available in Power BI where you can show them, like for example Asia is this much and Europe, like you will get a graph. Okay, I'll show you when you go to Power BI class. Ranking, first rank, second rank. Okay, so Mumbai sale is high comparing to Chennai, your ranking. So then also same thing. The correlation, very important, we will see in the class. Okay, this is one thing that we need data to completely understand. So correlation means if one is dependent on the another. Very important one we will see in the class. As of now, comparison, change over time, ranking, correlation. Okay, distribution is the one that we learned about, like box and whisker. See box plot. Can you see this one? So we learned about boxer. You can plot it in a histogram. You can plot it in scatter plot. So scatter is there. So we learned little bit about distribution, but we will plot everything in our Excel class. So mainly focusing on the comparison, change over time, distribution, correlation, ranking. Okay, rest other things you keep it for your advanced modules. So I'll send this visual presentation as reference. Just keep it, but when you are plotting on your own, you will kind of get a little idea. Okay. Okay, so I will stop this class because we just have to cover one small topic, types of machine learning. But since it's getting late, so what I will do, I will stop the class, and maybe when we are having Excel class, just one small topic, it will take only 5 or 10 minutes to tell you the division of machine learning. That I will take in your Excel class. So next week, Excel starts. Saturday and Sunday, and next Saturday is your 3 Excel class. Okay, until then, revise and just try to understand. So even if it's not coming, if it's not completely understand, it's okay. But we will, when you're seeing the actual modules, you relate and then try to understand. Okay, so that's it from my side. Any other doubt?
Yeah, Vandana, actually for the IQR, that logic that you have added in the Excel, it is not present in the one that you have shared.
Oh, okay, fine. Because my system got suddenly I lost the current, and that's okay, fine. I'll add and upload it in your LMS.
Sure, sure. Okay.
Okay. Okay. Any other doubt?
Yeah, one more. Actually, the Excel in fundamentals that you have shared yesterday, in the
Okay.
outliers, like we have two type of fence it was showing. One is outer, another one is inner. So
So
what
I
does
think that
inner
is
fence?
that is the one which we did below range and above range. Is the one? I think IQR one minus, if it is minus, that is inner range.
That is one lower inner fence, upper inner that lower outer fence and upper outer fence. Like four details are in
Okay,
the
I'll get
down.
to that point. Uh, okay, I'll share the screen very quickly. Okay, I got it. I got the point. So I think this is the one you're talking about. Okay. So our IQR is one which we calculated. Okay.
Yes,
Lower
yes.
minus. Okay. This is fine, right? Actually, there is one thing that this is 1.5. Okay. 1.5, which means like um, almost 90%, 99, 95% of your data is included. Okay, it is even about or you want to extend that range, which means like, for example, we have kept our range according to our calculation, whatever we did in the class, we have extended up to 1.5 times of this particular one, and we got, but you want to extend the range much further. So some people, what happens, they will take the full range 3, so plus or minus 3. So they will take 99.99% of your data into the picture. Okay, less rest the 0.01 data, they will consider it as an outlier. So they are including more range here, that's it. But the acceptable one is, according to the calculation, it is 1.5. But if you want to extend the range, which means you are extending -3 to -507, and if you are increasing 1 2 to 1679, so this is a rare case of calculating this range. Okay, they are extending the range. They are here, almost all the points will be captured inside this range. If you want to extend this range, for an example, you want to, if you think that BMW is not an outlier, or some other company that is more than BMW is an outlier. So you want to include BMW, but you want to throw away, let's say, I don't even know the name of luxurious car. So let's say X as a luxurious car. You want to include BMW, but you want to exclude this very, very outer range. That's why we calculate 3. Got it? Little bit?
Yeah.
Okay. So let's say a simple example, you plotted your scores of the students. Okay, let's leave the BMW and other things. Okay, this is starting from, they have scored from 20 marks to 99. Okay, so here only very rarely one student have scored 100. Okay. Consider like that. And very rarely one student have scored 10. According to 1.5, our range will be like this. According to our range, anything below 20 is considered as an outlier, lower range. Anything above 95 considered as an outlier. Okay, let's say for an example, according to 1.5. But we are extending this range. We are extending this lower and upper fence by using 3. So what happens? All the rarest case also be included. Very, very rare case, like one guy only scored this 10. So you are eliminating that one guy. And here also you have included all that case, one guy have scored 100. So you are eliminating that 100. So you're just extending this range. That's it. Very rare case you will go through that 3. Otherwise, this is our standard formula.
Got it.
Okay.
And one more.
Yes.
Uh, I mean, right now we got to know about the populace variance for populace variance. So, what is the difference related to, I mean, in between populace and sample variance? Like,
Okay. Sorry.
the value actually, when I checked it, it will differ actually sometimes. So, when do we use this one and when do we use that one?
So when do we use, like for an example, this, if you're working on engineering students of whole Tamil Nadu and your work is based on whole Tamil Nadu, then you will take population. But let's say you are picking 2-3 students from Chennai, 2-3 students from Madurai, and so you are taking sample. Then you apply sample. I was about to open that. So sample, when you are working upon sample, you apply that formula. But when you are working with full data, so when we use full data, so sometimes you see this Contoso data that you will be working or you will be using this for Power BI. See, even to open the data itself will take time. It has 3 lakh rows. But let's say you don't want to work with such a huge amount of data. You take sample from channel number, so 100 sample from each channel. Then you apply the sample variance. There is no difference between population and the sample, just divided by n and n minus 1. And n minus 1, I don't even know why this n minus 1, because it's completely, when I try to read, it's like full statistical formulas and other stuff. So nobody will ask why this is n minus 1. I'm very sure on that part. Why population is n, why sample is n minus 1? Because it's a deep jump into your statistics. So we are not statisticians, so keep that in mind. We are only analysts. So nobody will ask you why it is n and why it is n minus 1. I'm 100% sure on this part. When you use population, when you are analyzing full Tamil Nadu's engineering student, use n. Even it is 1 lakh student. But here when you're taking sample, 500 from Chennai, 500 from different district, then you use n minus 1. That is one small difference. Okay, so I pasted both the formula for you guys to understand and study. Even here also, variance by n, sample variance n minus 1. Rest all formula remains same.
So it will be same for a standard deviation as well, the
Yes,
formula.
n minus 1. So formula remains same. Okay, and then the down below, just a small change. That's it, n minus 1. So again,
And
one more time, we will again write the formula. Okay, so variance formula, summation of each individual data minus mean. the whole square divided by n. Okay, this is for population. And summation of your xi minus mu, the whole square divided by n minus 1 sample. This is your population. Standard deviation, you are not doing anything same way, but we just added the square. You are bringing back to normal by doing square root of the whole answer. That's the difference between variance and the standard deviation. The rest other things remains same.
Okay.
Yeah. Just because you're doing square, you're bringing back to the normal state and represent it properly, like whatever units you want. Okay. So any other doubt? So, okay, guys, then fine. Is it okay? Okay, check your LMS. All the notes will be there. And next class, Excel, just make sure your Excel is ready. At least the latest version 2010. Okay, anything that is below 2010 may not work properly. All the formulas and PO table, dashboard, it's going to be difficult. At least 2010, but latest version is the best. Okay, better for the projects. Okay, guys, then see you guys next class. Thank you.
Thank
Thank
you,
you.
Vanthana.
Thank you.
Thank you,
Thank you,
ma'am.
sir.
Thank
Thank
you.
you.